Greetings, pre-calculus students. It's Mr. Winter back at you. Last time when we were doing our trig graphings, we had talked about the trig parent functions. We had also talked about the effects of A and D on the graphs, what transformations those were. Again, if you recall, A could be a reflection if the value of A was less than 0. If it was negative, A could also be, it's basically referred to as what's called an amplitude, which is a big fancy name for the distance or half the distance from the top to the bottom, or the distance from equilibrium to the peak or the valley, that kind of a deal. It's also like a stretch or a compression. And then we talked about D, that parameter, which was your, that's really dreadful. Hang on just a second here. Your vertical shift. Hi. Before we talk about B or the frequency, I want to get good at C, and then we'll talk about that. C is what is called a phase shift. What is a phase shift? Phase shift is a shift to the left or the right. You're shifting the phase, you're shifting the function to the left or the right. It's horizontal shifting is basically what's going on. So let's do a little erasing here and take a look at some of these problems and see if we can come up with some nice graphs. Again, if you know your parent functions, this should be pretty easy. I need you to, let's start here. I know that the sign is periodic. It's going to continue on and on and on. Its domain is negative infinity to infinity. I just want to graph one cycle. And we've been doing this quite a bit, so I'm hoping that you've gotten pretty good at it by now. There is one cycle or one period of the one pattern of the sine function. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi at 0. Now if I look at here, and I look at my transformations here, I see that I have this x plus pi over 4 right there. Looks like it's the same here. So I have a change in C. Now, remember how this works. A lot of people say, well, look, C is pi over 4. And that's positive, so I go to the right. That's not correct. Notice this says x minus C. So it's negative C that matches up with pi over 4. So C is nearly negative pi over 4, which means it's going to move to the left, pi over 4 units. Again, if you look at the scale on my graph paper, it takes 1, 2, 3, 4 of these little grids to go pi, which means each of the little grids is pi over 4. So all I do is take this point and move it one grid or pi over 4 left. This, one grid or pi over 4. And I just kind of keep going that one little grid or that little pi over 4. Shift to the left, which gives me something like that. It's really not too bad. Okay, let's try this guy. Let's go with blue here. Again, cosine starts at 1, 0, negative 1, 0, and back to 1. That's one cycle, one period of my parent function for the cosine. And then I look here, and what do I see? I see that what I have, well, let's write our equation again. Y equals A times some trig function of b x minus c plus d. So I have an x minus pi halves where this has an x minus c. So basically what that tells me is that negative c matches up with negative pi halves. If I divide by negative 1, c is a shift of a positive pi halves, which means I'm moving to the right. Or like we had talked about earlier when we were doing the parabolas and all that jazz, if this is minus, you go the opposite direction. But basically, I'm going to take each and shift pi over 2 to the right. Now again, look at your scale. It takes 4 grids to go pi. So then what does it take to go pi halves? Well, it takes 2 little grids. So I'm going to shift this pi over 2 to the right. This pi over 2, or 2 little grids to the right. Same thing for all of these points. And there you have your graph. Now, just for kicks, I know I only asked you to graph one cycle of the function, but let's go ahead and just kind of think about it. I know this is periodic. Like if I keep going with my new graph, it's going to go like here and here and here like that. It's going to keep going. Where would this point at 1 be if I went back pi over 2 to the left? Well, it'd be right here at 0. And what do you see? What does this graph right here look like? Does that look familiar? So yeah, what I hope you see is that this graph of the cosine being shifted pi over 2 to the right is really the same as the sine of theta. So basically the sine and the cosine, they're the same graphs, just with a phase shift of pi over 2 in a certain direction. We'll deal more with that later. I just wanted you to see it. Okay? 3 and 4. Let's do a little tangent work. Now, here's where it gets a little messy. My preference for doing tangents is this. I know that typically my tangents have asymptotes at odd multiples of pi halves. So I like to use negative pi halves and positive pi halves, but I guess certainly you could go pi halves and 3 pi halves and 5 pi halves and 3 pi halves and all that jazz. You could do that, but I like to do these. Rather than making the whole parent graph, well, let me show you. If I were to just make the whole parent graph here, and then again, I know that the tangent has a 0 right in the middle. Pi over 4 is 1, negative pi over 4. So there's my parent for the sine, or for the tangent, excuse me. If I were to do this with my shifts, again, I see a phase shift of pi over 4, and since this says minus right here, I know that that's going to mean I'm going to go to the right. So this asymptote right here is going to shift pi over 4, or one little asymptote to the right, or one little grid to the right. This asymptote likewise will shift to the right. So where we had talked about our vertical shift and our amplitude not changing the asymptotes, they definitely change here. Now, the blue asymptotes are my new ones, and they're 1, 2, 3, 4 little boxes apart. What's significant about that is that 4 little boxes is pi, it's the period. So if I go 2 little boxes, that's my new 0. And then over a pi over 4, 1, left pi over 4, down 1. This is just nasty. It's not a good time to look at. It's really hard to decipher which asymptote belongs to one. So you can do it this way. I certainly would not count it wrong. It's not incorrect. However, let me show you with what maybe you might find to be a little easier to go with. On a problem like this, if you don't graph the parent function, I'm really not going to lose any sleep over it. So if I were to really just do this one, I would say like this, okay? Normally, there's where my asymptotes lie, at negative pi halves and positive pi halves. What do I got going on here? Well, I've got a horizontal or a phase shift of pi over 4 to the right. How much is pi over 4 on this grid? Well, pi over 4 is one little grid, so this thing, this asymptote, really is going to move to here. Again, this asymptotal shift pi over 4 to the right. So, in other words, all I did was just write down where the new asymptotes would be based on where the old ones were. So instead of being here, I shifted it pi over 4 to the right. Instead of here, pi over 4 to the right. Again, what happens in between the two asymptotes? Halfway in between is a 0. If I go over one little grid or pi over 4 to the right, that's at 1. One little grid or pi over 4 to the left, that's negative 1. And there is my transformed graph. So again, if you don't want to graph the parent function or don't need to graph the parent function for the tangents because you say, oh, it looks nasty, it looks messy, I get it. That's kind of what I do too. Okay, multiple transformations. I see a 4 here. I know that's an amplitude of 4. And since that is larger than 1, I know that it's going to be a vertical stretch. I also see a phase shift that I'm going to go pi units. Since that says minus right here, I know that's going to be to the right. Again, if that confuses you, think of this as like an x minus c. So it's not c that's this minus pi. It's really negative c. So then c is really positive pi, which means to the right. So I am going to graph the basic function. So I've got my sine normally starts at 0, then 1, then 0, then negative 1, and back to 0. Again, I'm just going to graph one cycle of the function, one period. Okay, now's where it gets a little crazy. Let's go purple here. Now let's go with this blue. I've got two things going on. I'm going to start with the amplitude. Amplitude. Here I am at 0. Again, what happens with the amplitude? Well, it's 4 times the sine of whatever your angle is. So I just multiply by 4. So what happens when I take 0, this y-coordinate 0, and multiply it by 4? Well, nothing. It stays 0. Then I shift to the right. So this point will actually shift to right there. Okay, now this might trip you out a little bit, but okay. So then what happens here at this point 1? Well, if I change the y value via my amplitude, I take 4 times this y value of 1, which puts me at 4. So 1, 2, 3, 4. And then I shift pi to the right, which is 1, 2, 3, 4 little grids to the right. This 0 times the amplitude of 4 is still 0. And then I shift pi to the right, which is 1, 2, 3, 4 little grids. Do you see the start of my sine function? This negative 1, again, if I multiply by the amplitude of 4, negative 1 becomes negative 4, so I'm at 1, 2, 3, negative 4, and then I shift 1, 2, 3, pi units to the right, which is 4 little grids. And then the end of my first cycle of the sine function was at 0. 0 times 4 is 0, and then I shift it 1, 2, 3, 4 of these little grids, or pi units to the right. So hopefully you see how all these little points shifted pi units to the right, and then also your amplitude got stretched. That is one way to graph it. If that works for you, beautiful, that's fine, so be it. It's kind of not my go-to. I will just show you what I do or what I know how to do, and then I'll leave it to you with what works most effectively for you. So again, let's go right back to our old buddy, the parent function. Again, we're talking about a sine, so 0, 1, 0, -1, 0, finishing at 2 pi. Oops, that went a little bit too high there. Let's try that again. Here's basically what I like to do. I like to approach it from this perspective. I like to find where it begins, then use the period to tell where it ends, and then I just fill in points in the middle. When we start talking about doing the change in frequency or the change in period, the B, I think you might find this method a little bit more favorable, so I'm going to show that to you guys right now. So let me show you how it works. I'm going to start with this point 0. Again, what are my transformations on that 0? Well, my transformations are, I have an amplitude of 4, which means I'm going to take the y value times 4, and 0 times 4 is, well, that's just 0. And then I'm going to do my phase shift of pi units right. So this point, when I multiply its y by 0, it's still 0. And then I phase shift it pi, or 4 little grids to the right. So this point, this original starting point, is now right here. This is where my graph starts. Okay? Now, what is the period of the sine function? Well, in previous videos, we talked about the period being 2 pi. Okay? Fair enough. And 2 pi on this, remember that 4 little grids on this particular graph makes pi. So what'll make 2 pi? Well, 8 little grids. So notice how the original sine starts at 0 and ends at 0. So since this starts at 0, I'm just going to do a period of 2 pi, so which is 1, 2, 3, 4, 5, 6, 7, 8 little grids. This point right here, so I have my beginning point here, which shifts to here, pi units to the right. This ending point shifts pi units to the right. The other thing to notice about your original function is you see how it begins and ends at the same y value? It also has a middle point that's the same. So my new graph begins here and ends here, which means it has another 0 right in the middle. That is my equilibrium line. That's my 0. That's my halfway point. All I need to do is an amplitude. You see how this goes up, like in the middle here, it goes up 1. So here, instead of going up 1, since I have an amplitude of 4, it's going to go to 1, 2, 3, 4. And then this part goes down to -1. My amplitude, which is right in the middle, go down 1, 2, 3, 4. So, same graph, same deal. Only what did I do? I just said, okay, I start here, I end here. Here's what happens in the middle. Here's what happens in the middle of the middle and the other middle of a middle. It may freak you out right now, but it's worth looking at for later times. Last two graphs. Another cosine graph. I pretty much threw the whole, oh, that's number 6, excuse me. Let's do another tangent graph. Transformations. I see the negative, so there's a reflection. And I see a shift of pi over 2. Since that says minus pi halves, I know that's to the right. So, do I want to draw the original and do all that? If you want, have a blast. I'm going to pass. I know my original asymptotes are here. Is having this reflection or multiplying by -1 going to change the asymptotes? No. The A does not change the asymptotes. Only this does. So what I'm going to do is I'm not going to graph the original because it's going to get too cluttered. I'm just going to say, you know what? This asymptote that used to be at pi halves is now shifted pi halves to the right. I'm sorry, that was at negative pi halves is now shifted pi halves to the right. This one that was at pi halves is now shifted pi halves to the right, which is 2 little grids, which puts me at pi. So those are my 2 new asymptotes or boundaries or bounds for this function. Now again, what happens in the middle between the 2 asymptotes? Well, normally I have a 0. Is there anything in here that'll change that, like a vertical shift? No. You say, well, it's reflected, but if you reflect 0 across the x-axis, it's still 0. Now, here's where it does get a little creepy. On the normal tangent function, you would go 1 little grid or pi over 4 to the right, and it puts you up at 1. So then what is the reflection here going to do? Well, it's going to put you down here at -1. And then this one normally goes left and down. Now it's going to go left and up. And there's your graph. Little kick for you later on. We'll talk about the graphs of like the secants, the cosecants, and whatever. When you do that reflection and you also do that phase shift right of the tangent function, this is really also the graph of the cotangent function. But again, another day, another time. One last one. I threw everything I could at you. Let's see how we handle it. I'm going to go via the parent function. If you can do it without, you have my blessing. So I got a cosine, starts at 1, 0, -1, 0, 1. Again, I hope you're pretty smooth with that by now. Transformations, I see 3 of them. I see a reflection. I see that I have an amplitude of 2. Again, I do not have an amplitude of -2. I have an amplitude of magnitude 2, which is a stretch, and it is reflected. And then I'm going to shift 3 pi over 4 units. That says plus here. That means I'm going left. Okay. Again, you have a couple of choices as to how you proceed from here. I'm going to go this route. I'm going to start with this first point, which is at 1. If I take my amplitude and my reflection, basically I have -2 times the cosine of whatever. So I'm going to take my y value and multiply it by -2. So instead of being at 1, it's really going to be right there at -2. But it's also shifted. Remember, each little grid on this graph paper is pi over 4. So what is 3 pi over 4? That is 1, 2, 3 little grids to the right. So this point right here is now located here. This is where what I was talking about on that other graph plays in very nicely. You see how the original parent function starts at 1 and ends at 1 like this? So since this one starts at -2, guess what it's going to do? It's going to end at -2. How long does it take for the cosine to do its thing? Well, the period of the cosine is 2 pi. How many of these little grids does it take to do 2 pi? Well, if it takes 4 little grids to go pi, it'll take 8 little grids to do 2 pi. So if I begin here, I end 8 little grids or 2 pi later. So 1, 2, 3, 5, 6, 7, 8. Those 2 points are taken care of. Now, halfway between there, see, like I have a beginning and I have an end. halfway between there, I have a -1. So halfway between there, I will have that -1 multiplied by the -2 from my reflection and my amplitude. So -1 times -2 is really 2. So halfway between my beginning and my end point, which is 1, 2, 3, 4 little graphs, I'm going to be up here at 2. And then halfway between there, between the beginning and that middle point, I have a 0. 0 times -2 is -2, so that's going to put me like here. And then I'm going to have another 0 right here. This may take a little bit of getting used to, but this is just kind of an introduction. We'll talk more about it via discussions in class and through our online conferences and stuff like that. But hope it gives you a start. I will post the homework for this later on, and talk to you later. Bye.